Welcome to an example. It says the depth in feet of water at a dock changes with the rise and the fall of the tides. That makes sense, right? So as the tides come in, the water level rises, the tides go out, it goes down. Well, they have equations to model all that kind of stuff. Scientists do all this kind of stuff. So there's our formula, and the D is the depth, like how deep the water is at a dock based on the time. Notice, T is the number of hours after midnight. And then they say find the rate, like how fast the depth is changing at 4 a.m. So that's when T is 4, because that's 4 a.m. is 4 hours after midnight. T is 4. So they want the rate. What does a rate mean? A rate always means a slope or derivative. A rate, how fast something changes, is a slope. Why? Why is that? Because remember, slope is rise over run. It's y over x. Rise is y up and down, run is x sideways. Y over x. And what is y in this problem? This is our function. This is our y, which is what? D depth. Depth, that's feet. That's feet depth. And what is x? Well, x is like t. T's playing the role of x. What is t? Hours, right? So feet per hour, like how many feet per hour the depth is changing. Slope and derivative, we've learned, is slope at an instant in time. So long story short, when they say rate on a problem, you take the derivative. So they want us to take the derivative. Let me bring the function down here, d of t. I'm going to use a capital T because I don't want it to look like a plus sign. 5 cosine. Okay, now I'm going to try to be clear with the inner and outer layers here. Pi over 3 t plus 4 pi over 3. It's all inside of that plus 4. Okay, so I want you to see we have an inside function, right? This is inside of cosine, and the cosine is the outside function, right? You might say, well, no, maybe it's multiplication. Isn't this cosine times this? No, it's never that way. Whatever's in parentheses after sine, cosine, or tangent, that's always the plug-in, right? That's how functions work. If I go f of 3, that means the 3 is plugged in. If I want to multiply the function, I put the number in the front. Numbers in front of a function like this 5, that's multiplying. But numbers in parentheses after a function are not multiplication. Those parentheses do not mean multiplication. They mean plug in inside the function, right? The same is true for f, g, or h and cosine, tangent, sine, cosine, tangent. It's all the same. So this is all plugged in. So then we go, oh, so I got to use a chain rule. That's a function plugged into a function. Exactly. We've got to use the chain rules. Function inside of it. How does the chain rule work? You have an outer and you have an inner, right? O stands for the outer function, and I stands for the inner function. When you have an outer and an inner, and you want the derivative, you do the derivative of the outside function, keep the inside unchanged, times, and then the derivative of the inside function. So here we go. Let's do it. So I'm going to go d prime and take the derivative. So you do the derivative of the outside function. So 5 just sits there because it's a multiplied number. The cosine is negative sine, so I'll go sine and I'll put the negative right there. Okay, and then keep the inside function with exactly the same at first. Like that. Oh no, what about this guy? He's 0. Remember, the derivative of any number added or subtracted that doesn't have an x is just 0. He's gone, he's just 0. But that 5, he's a multiplied number. He's not added. He's multiplied. So those sit there like a spectator watching the event happen. And the derivative of the cosine is negative sine. And then this is the I right there. So you see I've got the O prime and the I. The derivative of the outside function, derivative of cosine is negative sine. The inside function stays the same. Now times the derivative of the inside function. So I'll do it in a different color. Times, and then right here, I'm going to put the derivative of the inside function, right? Derivative of the inside function. So the derivative of this inside function. Now, this is where you got to remember, your t is your x. That's like x. It's exactly like x. It's just t. That's our variable. Okay, now pi over 3 can throw you off. That's just a number. Remember, pi is just 3.14159, blah, 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 blah. Who cares? It's just a number. This is the same thing as saying 2/3 x. Just think of this as 2/3 x. What's the derivative? Well, it's x to the first power. The 1 comes down and multiplies, and then subtract 1 from the power, and the x goes away. So it's just going to be the pi over 3. Does that make sense? Because it's a 1 power. That 1 just multiplies pi over 3, which is just a number. That doesn't change it. Subtract 1 from the power. T to the 0 goes away. And then what about 4 pi over 3? That's 0. Again, it's just a number. Pi is just a number. So 4 pi over 3 is just a number. The derivative of any number that doesn't have a t. Now, if it had a t next to it, or a t squared or something like that, or a sine of t or cosine of t, then we would leave it be. But numbers that are added or subtracted that are not multiplied next to a letter, just the derivative is just 0. So there's the derivative of the inside function, just like that. Okay, now they want us to plug in t is 4. So let's do it. So now we're going to go, all right. So we want d prime of 4. We're plugging in because we want to know at 4 a.m. what's the rate of change? How fast is the what do they call it, the depth changing? Well, so just simply plug in a 4 right here for t. Yeah, and that's it. So it's going to be -5 sine. This is going to be pi over 3 times 4 plus 4 pi over 3 times pi over 3. Now, make sure that you're in radian mode. Because remember, whenever we plug into a trig function in calculus, it's automatically radian mode unless they specifically say degrees. So it's going to be radian mode. So now we're just going to go to the Desmos calculator. Want me to do this one with you? A lot of times I just say, just hit the buttons, but this one's a little messy. I could show it. Okay, I just wrote it down. All right, I'll do it. So I'll go to the Desmos calculator. Find it here. Okay, so here we go. -5 sine. What's going to go in? There's pi over 3. So pi over 3 times 4 plus 4 pi over 3. Boom, boom. Times pi over 3, huh? Pi over 3. Boom, there I'm getting -4. Oh my, and I'm rated. See the modes? See degree rating, degree rating. That'll change it. Make sure you're rating mode. -4.5344. See if that's right. Beautiful. -4.534. They rounded it to 4.5. And there it is. So that's how we do that. Chain rule.